Hello learners, welcome to week 4 of our course on Introduction to Electric and Hybrid Electric Vehicle. In the last week we had a detailed discussion on the hybrid electric vehicle and its different configurations along with the associated technologies. This particular lecture may be considered as the extension of the last week's discussion that we had. In addition to this, in this week we will discuss on plug-in hybrid electric vehicle, fuel cell vehicle along with the detailed comparison among different vehicle configurations. So, the hybrid electric vehicle and their different configuration discussed have the mechanism to charge the onboard battery from the power supplied by IC engine only. In that, there is no provision to charge the battery from power outlet. Plug-in hybrid electric vehicle have been introduced to fill this gap as it provides the provision to charge the onboard battery from the external power outlet or from the charging system placed either onboard or offboard. So, if you see the component of plug-in hybrid electric vehicle, it seems more or less similar to the hybrid electric vehicle, only with the one difference that we will discuss later. But as of now, before getting the technical discussion on plug-in hybrid electric vehicle, so let us define the plug-in hybrid electric vehicle. According to the IEEE Board of Directors, a plug-in hybrid vehicle is defined as follows: any hybrid electric vehicle which contains at least one battery storage system of 4 kilowatt hour or more used to power the motion of the vehicle, and a means of recharging and battery system from an external source of electricity, along with it should have ability to drive at least 10 miles in all electric mode and consumes no petrol or diesel. It means a plug-in hybrid electric vehicle is a hybrid vehicle whose battery can be recharged by plugging it into an external source of electric power as well as by its onboard engine and generator. This definition highlights the dual capability of plug-in hybrid vehicle to recharge their battery from an external electrical source and through the conventional internal combustion engine and generator system available within the vehicle. In this vehicle, not only fuel tank but also battery pack can be recharged by external source to extend the all electric range of or all electric operation of the vehicle. When the battery pack is fully charged by external source, plug-in hybrid electric vehicle operates as electric vehicle with extended all electric range, and then it switch to hybrid mode when either battery reaches to its predefined state of charge or vehicle demands extra power for acceleration. It is quite obvious that all the available hybrid electric vehicle configuration can be easily converted to plug-in hybrid electric vehicle. What does it mean? It means that the configuration of hybrid electric vehicle have very much similar configurations that we have in case of series hybrid electric vehicle. So, in series hybrid electric vehicle, the moment you connect a battery charger along with a provision or plug to connect it with the power outlet, it becomes series plug-in hybrid vehicle. Similarly, in a parallel hybrid electric vehicle, if you connect the battery with a battery charger and a plug to plug it with the outlet utility, the parallel hybrid electric vehicle becomes the plug-in hybrid vehicle of parallel configuration. Similarly, in a series parallel combination, if you place battery chargers and mechanism for connecting it with the utility grid, the series parallel hybrid electric vehicle becomes the series parallel plug-in hybrid electric vehicle, and it is equally true for complex hybrid electric vehicle with the charger and connecting mechanism. You can with the connecting guns you can convert or transform the complex hybrid electric vehicle into a complex plug-in hybrid electric vehicle. So, in the architecture point of view, there is not much difference in a plug-in hybrid electric vehicle. It is similar. Based on their configuration, we can derive the different combination as series plug-in hybrid electric vehicle, plug-in hybrid electric parallel plug-in hybrid electric vehicle, series parallel plug-in hybrid electric vehicle, or complex plug-in hybrid electric vehicle. So, plug-in hybrid vehicle is a transitional technology between battery electric vehicles and hybrid electric vehicle. As one can see that the configuration of plug-in are very similar to hybrid electric vehicle. The difference between them, the normal hybrid electric vehicle and plug-in hybrid electric vehicle, takes place in terms of battery charger as mentioned. This gives this inclusion of the battery charger along with the connecting gun gives the flexibility and freedom to place higher capacity of the battery on board, resulting higher all electric drive range and lesser emissions and better efficiency. Similarly, it creates a new avenue and the area where the integration of the hybrid electric vehicle and grid can be studied in detail with greater length. So, if you discuss about components of a plug-in hybrid electric vehicle, as you have seen, it has same component as hybrid electric vehicle has, like fuel tank, IC engine, exhaust system, battery, traction motor, power converter, thermal management system, etc. In addition to this common component, plug-in hybrid electric vehicle has two more components or two more parts that creates the difference with the conventional hybrid vehicle. The first one is the charging port. The charge port allows the vehicle to connect to an external power supply in order to charge the onboard traction battery, and another one is the charging mechanism. This charging mechanism or this charging system can be a onboard charging system or it can be a off-board charging system. On-board charging system is something which is an integral part of the vehicle, and off-board charging system is something that remains outside of the vehicle. So, this charging system takes the incoming AC electricity supplied via the charge port and converts it to DC power for charging the traction battery. It also communicates with the charging equipment and monitor battery characteristics such as voltage, current, temperature and state of charge while charging the battery pack. While monitoring this voltage, current and temperature, this charging mechanism or this charging system can devise a suitable mechanism and rate of charge at what rate rate of speed of charge, that at what rate the battery has to be charged, keeping the battery life and battery health into consideration. As mentioned earlier, that all possible configuration of hybrid electric vehicle can be transformed into plug-in hybrid electric vehicle. Hence, the different attributes and operating modes associated with particular configuration of hybrid electric vehicle are equally applicable for plug-in hybrid electric vehicle. To avoid the redundancy, the different attributes and operating modes have not been discussed here. In nutshell, the different operating mode for plug-in hybrid electric vehicle can be summarized as electric mode. The vehicle runs only on electric motor using energy from battery, as it has got the freedom and flexibility to charge the onboard battery from external power outlet. It means the battery size can be increased, and when the battery size is increased, you can take more traction by electric propulsion system. It is this particular mode of operation is ideal for short trips and urban drives with practically no emission or zero emission. Another mode is the hybrid mode, combines power from the mechanical propulsion system and electric propulsion system, and it provides a greater thrust which is encased in hill climbing or highway cruising. Also, it optimizes the fuel efficiency by using the electric motor for low speed driving and the IC engine for high speed or heavy loads. Even in this hybrid mode, there is a possibility that during hybrid mode of operation, the mechanical propulsion system is supplying power to wheels, and at the same time it can generate power or it can deliver power to the battery as well, and in that way battery can acquire energy further. So, this hybrid mode can happen in both way. The battery, electric propulsion system and mechanical propulsion system can deliver power together to the wheels of the vehicle, or the mechanical propulsion system can deliver power to the wheels of the vehicle and the part of energy can be given to the battery. So, the electrical propulsion system can deliver power as well as it can receive power. Another one is a charge sustaining mode. In this, the mechanical propulsion system generates electricity to maintain the battery's charge level, ensures that the battery does not get depleted completely. Another one is the charge depleting mode. In this mode, the vehicle primarily uses the battery until its charge is depleted, and this particular mode also helps in maximizing the all electric range of the vehicle. So, this is the different mode associated with the operating of plug-in hybrid vehicle. I should say this is the glimpse of the different operating mode associated with the plug-in hybrid electric vehicle. So, let us have a short video prepared by Honda for its hybrid vehicle, to explain its hybrid vehicle concept. This video explains the operation of the hybrid electric vehicle as well as plug-in hybrid electric vehicle. So, in this we can see the combination of the large battery and high output motor provides an accelerating power to the motor, and the motor drives the vehicle in completely charge mode. In this particular case, the electric propulsion system alone supplies power to the motor and motor runs the wheels. It means it is purely running on EV drives or on electric propulsion system. On other mode, it is a hybrid mode. The fuel efficient powerful engine and two motor system work simultaneously in hybrid drive mode. This particular mode is applied for highway cruising and hill climbing. It provides huge amount of thrust to the wheels, so that all the vehicle operation that requires high power and demands more torque. In this case, the IC engine, the mechanical propulsion system or electrical propulsion systems are combined together, and that amount of power is being delivered. In another mode, as one can see, during excessive acceleration or hybrid acceleration, the additional power of the battery is taken to enhance the acceleration of the vehicle, and the vehicle goes into the full throttle. In this particular mode of operation, hybrid charge, because of the momentum or the braking mechanism, the energy which is being extracted by momentum of the vehicle is fed back to the battery, and battery gets discharged. At a highway cruising speed, the fuel efficient and powerful mechanical propulsion system is the main source of power, and it alone drives the vehicle to its full capacity. And this particular mode deals with the regeneration mechanism. During braking, deceleration, a significant of energy is being recovered and it is fed back to the battery for further charging. And during non-operation times, this vehicle can be connected to the outside power outlet, and this power outlet can charge the on-board battery, which gives the additional extended all electric range. This charging can be done as a slow charging or level 1 charging, or it can be done as a fast charging. In addition to this well known operating modes, there are some additional operating modes that comes with a plug-in hybrid electric vehicle. These modes are the results of the integration of the hybrid electric vehicle with grids, and these modes are known as grid to vehicle and vehicle to grid. These modes are only possible because of the integration of the hybrid electric vehicle with the power grid. So, in grid to vehicle, it is a concept when the grid supplies power to charge the onboard storage battery of the plug-in hybrid vehicle during charging mode of operation, and during vehicle to grid it is quite interesting and very highly researched area where the amount of power which is stored on the battery can be fed back to the grid. Means it is a concept when the onboard storage system fed power back to the grid during battery discharging mode of operation. The grid to vehicle or vehicle to grid, this both the mode of operation happens when the vehicle is at standstill or when the vehicle is not in operation on the road. So, this schematic explain both the concept G2V and V2G. It is a simple schematic in that you can see during charging of the onboard battery, utility grid supplies power to the battery, and the supply of the electrical power takes place either through home charging or through a bidirectional converter or an external charging station. All three can be a part of it, or either it can be charged through home or it can be charged through charging station. In case of vehicle to grid applications, this grid has to be connected to the bidirectional converter. This bidirectional converter comes in form of on-board charger or off-board charger or a charging system or mechanism that is installed at a home. It enables V2G facility of plug-in hybrid electric vehicle. The concept of vehicle to grid is emerging technology which offers bidirectional operation or bidirectional power flow, so that grid can transfer power to the vehicle in charging and vehicle delivers power to the grid in discharging during peak hours. All vehicle with V2G capability must meet the IEEE standard of 1547 for connecting to the utility grid. It is one of the essential requirement for connecting any vehicle to the grid. The G2V or V2G concept utilizes the plug-in hybrid vehicle's battery as a storage medium for electricity. When the vehicle is plugged into a charging station, draws power. Conversely, when the grid experiences high demand or the vehicle battery is fully charged, this can be discharged and it can be used as a backup for power supply. So, there are key components for this G2V and V2G application of the plug-in hybrid electric vehicle, and these components are the battery management system. It manages the battery health, charge and discharge process. As in V2G or G2V, the battery has to go through the frequent charge and discharge, and this might create an adverse impact on the battery's health. So, a battery management becomes essential for smooth operation of the G2V and V2G concept. It ensures, this battery management system ensures the safety and efficiency of the V2G and G2V process. Another important component is the bidirectional charger. It can be on board or off board as mentioned earlier. It converts AC power from the grid to DC power for charging the battery. It utilizes the power electronics converter and control mechanism for regulating the charging and discharging of the battery under the consideration or the based on the input received from the battery management system. Another important component is the grid interfacing. while interfacing the vehicle with the grid, one should take care of the different norms which is required for the grid interfacing of the vehicle. As I mentioned, the IEEE 1547 standard has to be followed. It supports the bidirectional power flow for advanced system. In addition to this, another major component is the communication interface, uses standards like ISO IEC 15118 for communication between vehicle and grid. It also, this communication mechanism or communication system facilitates the demand response and load management. These two are very important, that this communication mechanism or this communication system is responsible for getting the onboard batteries information, its SOC. At the same time, it also conveys the amount of power available on the grid. It might be possible that grid is on its peak load and it is getting difficult to push power to the vehicle. In that case also, this communication mechanism plays a crucial role for creating coordination and synchronization between exchange of power from vehicle to grid and grid to vehicle based on the availability of the power on either side. So, the integration of the vehicle with grid brings lot many advantages and benefit to the system. One of the benefit is the improved grid stability. By allowing plug-in hybrid electric vehicle to store and discharge electricity, the grid to vehicle helps balance the grid's power supply and demand, reducing the risk of blackout and burnout. Though the battery capacity is higher in comparison to hybrid electric vehicle, but lesser in comparison to fully electric vehicle. So, again it is interesting to see how much amount of power it can support. Certainly a single vehicle cannot provide that much of support, but the multiple vehicle at a time, if connected to the grid, it can deliver a good support. It enhances the vehicle range. By utilizing the grid G2V system, plug-in hybrid electric vehicle can extend their range by charging their batteries from the grid, reducing the need for frequent refueling and also dependency on the IC engine for drawing the charge. It also resolves the different issues and provides the benefit of integration and utilization of renewable energy sources. It resolves beautifully the intermittency associated with the renewable energy sources, like the plug-in electric vehicle can charge during period of high renewable energy generation, helping to mitigate the intermittency of renewable source like solar and wind. At the same time, it creates a good balance of penetration of the power to the grid and to the vehicle for charging, and also it helps in storing the, it acts as a distributed energy storage, enhancing the grid stability and renewable energy penetration. So, the plug-in hybrid electric vehicle handles two major issues associated with the efficient utilization and usage of renewable energy sources. One in terms of handling its intermittency, and another one storing the energy by acting as a distributed energy source. Another key benefit comes as an emergency power supply. In the event of a power outage, grid to vehicle enabled plug-in hybrid vehicle can provide backup power to homes, to business and to different load, and it brings the concept of V2X. It means vehicle can supply grid, vehicle can supply home, vehicle can supply appliances, or vehicle can supply any other electrical equipment which requires power. So, that features and facility are also gets enabled by G2V or V2G concept. So, as by these benefits and aspects associated with the interaction of hybrid electric vehicle with the grid, it makes evident that the grid integration of the hybrid electric vehicle by means of plug-ins open up a new avenue for further research and development. Some of the advantages of the plug-in hybrid electric vehicle can be fuel efficiency. It enhances the fuel efficiency, combining the high efficiency of electric driving with extended range of IC engine vehicle, and it reduces overall fuel consumption. It helps in minimization of the emissions, contributes to cleaner air and reduces the environmental impact, because the onboard energy sources can be charged by renewable energy, onboard battery can be charged by renewable energy source. So, it has further good impact on the environment and human health and reduces overall CO2 emission. Flexibility and convenience, it has ability to switch between electric and IC engine. Power provides flexibility for longer trips, reduced range anxiety compared to all electric vehicle, and it saves overall the cost saving. It brings the advantage of cost saving, lower operating cost due to reduced fuel consumption and maintenance, and potential savings on a fuel, and because of the government incentives for hybrid electric vehicle which is being offered by different region, and it varies based on the states to state and country to country. So, in addition to these beautiful advantages that plug-in hybrid electric vehicle brings, it also brings some challenges, and some of the challenges that comes with the plug-in hybrid electric vehicle are higher upfront cost. Plug-in hybrid electric vehicle are typically more expensive to purchase than traditional IC engine vehicle, and it has limited charging infrastructure. The charging infrastructure for plug-in hybrid electric vehicle is still developing, and which can be problem for some drivers. In few countries they have very good charging infrastructure, but for country like India we are still developing our charging infrastructure. So, the better charging infrastructure will further boost the advancement and development of plug-in hybrid electric vehicle. If we talk about the future aspect of the plug-in hybrid electric vehicle, then it should require some technological advancement. This technological advancement should come as improvement in a battery technology, and that should improve the longevity of the battery, and this longevity of the battery will enhance the range of the vehicle, and the enhancement of all electric range of the vehicle will further enhance the overall efficiency of the vehicle. Another advancement is required in the power electronics converter and their control for better optimization of the space and size and overall performance of the vehicle. And again, the future aspect is with the integration of the renewable energy. The plug-in hybrid electric vehicle can be integrated with the renewable energy source for sustainable charging as discussed and all, and again it will cut down the dependency on the fossil fuels. The electric vehicle which is coming from grid is some way or other being produced by burning of the fossil fuels, by burning of the coal, which is another form of fossil fuels. So, the more and more penetration and integration of the renewable energy with the existing grid will significantly minimize the dependency on the fossil fuels, and it will take this alternative transportation or electrified vehicle into more sustainable side. So, that is an overview of plug-in hybrid electric vehicle and some of the associated stuffs with it. Now, let us dwell into some of the commercial vehicle models available based on plug-in hybrid electric vehicle. So, one of the most popular plug-in hybrid electric vehicle commercially available is Toyota RAV4 Prime, and it is launched in 2020, and it represents significant advancement in hybrid technology, offering impressive performance, efficiency and versatility. This study explores the RAV4 Prime's features, benefit, challenges and its impact on the automotive market. Toyota has been a pioneer in a hybrid electric vehicle since introduction of the Prius in 1997, and that's why in discussion of the hybrid electric vehicle and its different configurations, the different model of the Toyota have been taken, and similar practice I am keeping here for discussion of the plug-in hybrid electric vehicle. So, the RAV4 Prime, a plug-in hybrid version of the popular RAV4 SUV, builds on this legacy. It combines an electric motor and traditional IC engine to offer both electric only and hybrid only driving modes. If we talk about the technical specification of this particular vehicle, it has 2.5 liter 4-cylinder engine, 2 electric motor for front wheel and the rear wheel, and the combined output is 302 horsepower, which is quite huge and delivers a high performance, and this high performance gives a better driving experience. It has a lithium ion battery with a capacity of 18.1 kilowatt hour, and it takes approximately 8 to 12 hours on low voltage charging, and it takes 2 to 4 hours on a fast charging or high voltage charging. If we talk about the performance of the vehicle, in electric range it travels on 42 miles, and in general combining electric mode and hybrid mode, it delivers 600 miles, and it reaches to 60 mile per hour just in a 6 second. As far as the fuel efficiency is concerned, its electric fuel efficiency is 94 mile per gallon, and hybrid fuel efficiency comes somewhere, or hybrid fuel economy comes somewhere 38 mile per gallon, while combining both IC engine and battery. So, it has a all wheel drive. It is a combination of the complex hybrid electric vehicle. The RAV Prime comes with a standard electronic on-board on-demand all-wheel drive operation, enhancing traction and stability in various driving range, and it provides the regenerative braking, and it recovers significant amount of energy from all the wheels. If we talk about the driving mode, offers AV driving mode, hybrid mode, auto mode, where it automatically switches from electric vehicle mode to hybrid mode. Next is the benefit that this electric vehicle offers, very much similar to the benefit that is offered by all other hybrid electric vehicle. It has minimizes the environmental impact and delivers better performance, and it has versatile operation. The ability to switch between electric and hybrid mode offers flexibility for different driving scenario, from daily commute to long road trips, and even this is taking place automatically. If we talk about the challenges, certainly it is cost is one of the biggest challenge. Charging infrastructure is another important challenge, and since battery is subject to frequent charging and discharging, so battery life may get degraded quickly. So, these are few things that needs to be taken care properly while dealing with the Toyota RAV4. So, in summary, the Toyota RAV4 Prime exemplifies the potential of plug-in hybrid electric vehicle to offer a balanced blend of performance, efficiency and practicality. It addresses many challenges associated with the traditional vehicles and fully electric vehicle, making it compelling option for a wide range of consumers. In comparison to Toyota RAV, there are other plug-in hybrid electric vehicle like Mitsubishi Outlander plug-in hybrid electric vehicle, which has 2.4 liter engine, and it gives the 61 kilometer of electric driving range. Another one is the Mazda CX-90 plug-in hybrid electric vehicle. It has 42 kilometer of electric drive, and it has 2.5 liter of IC engine. Another one is the BYD Song Pro. It has 81 kilometer of electric drive and 1.5 liter turbocharged IC engine. So, these are some of the competitors or available options of the plug-in hybrid electric vehicle in the market. So, the vehicle models that we have discussed based on the plug-in hybrid vehicle architecture represents the significant achievement in the market, offering compelling combination of the performance. All model addresses many challenges associated with the traditional vehicle and fully electric vehicle, making them viable options for a wide range of consumers. As technology advances and the market evolves, these plug-in hybrid electric vehicles are poised to play a crucial role in the transition to more sustainable transportation solutions. So, in summary, plug-in hybrid electric vehicles are ideal for motorists who want to use their car in a variety of ways. You can use the electric motor for daily commutes, but also take advantage of the great range and flexibility of petrol engine when you go on a longer trips. So, this is all associated with the different aspects of plug-in hybrid electric vehicle, whether related to its working, operations, some of the operating modes, V2G and G2V applications, and different benefits which is coming because of the integration of hybrid electric vehicle and utility grid. Let us have few quiz just to brush up or to revise the discussions that we have related to plug-in hybrid electric vehicle. So, the first question that we can take is, what is the primary advantage of plug-in hybrid electric vehicle over a traditional hybrid? So, if you go through the options, better fuel economy, longer electric only range, lower cost, more powerful engine. Though it seems all of the answers are true, but the best suited answer for this particular question is longer electric only range. Another quiz is, what is the main component responsible for managing the power flow between the electric motor and the IC engine in plug-in hybrid electric vehicle? So, among the given options, it seems quite obvious that it is a power control unit is the main component which is responsible for managing the power flow between the electric motor and the IC engine. Another important question that we can take, how can government policies encourage plug-in hybrid electric vehicle adoptions? So, there are several ways. One of the ways could be offering tax incentives, building charging infrastructure, increasing fuel price, or all of them. But you give a close thought to the given options, certainly you can come to know that by providing the tax incentives and by creating the building charging or by creating a good charging infrastructure, you can encourage the adoption of plug-in hybrid electric vehicles. So, in this particular question, the correct answer will be both A and B. What is the main environmental benefit of using a plug-in hybrid electric vehicle? Certainly, it could be reduced greenhouse gas emissions. So, these are some of the quiz. By going through this quiz, you may get a quick revision of the different aspect that has been discussed related to the plug-in hybrid electric vehicle. So, today we have discussed on plug-in hybrid electric vehicle, its configuration, working, operation along with the benefits and challenges, followed by discussion on V2G and G2V applications, and which emphasizes the opportunity of integration between hybrid vehicle and grid. I hope this lecture helped the learner to expand their understanding related to the plug-in hybrid electric vehicle. So, that is all for this lecture. Thank you so much.